Okay, so I am just going to do the examples that were skipped in class today, just for some extra practice. So looking at number 2, whenever you guys solve by rooting. So rooting is when you only have one spot with one variable. So I just have that x squared. So rooting just means algebraically, we are going to solve to get x by itself. So I start by adding my 31 over. And then I divide my 4. And then once you have the square root by itself, that's where you take your square root, because the square and the square root will cancel. 20 is not a perfect square. However, 4 times 5 is 20. When that 4 comes out, the square root of 4 is a 2. I leave behind a square root of 5. And then whenever we take a square root, we have to throw in plus or minus. So this graph would hit the x-axis 2 times, once at positive 2 root 5, once at negative 2 root 5. The next one that we skipped, we'll do number 8. So, step 1, get the thing with the exponent by itself. So here, a little bit different than what we saw in class. That one's on the inside. So this 1/4, I'm just going to undo that right away. There's nothing else to move over, so to undo a 4, the 4 is on the bottom, I'm going to multiply both sides by 4. Those will cancel, so I have n squared plus 8. If I just have a 1 in front, it's not going to change anything. 20 times 4 is 80. Now I'm going to minus my 8 over to give me 72. When I get my n squared by itself, that's when I can take my square root. Those will cancel. 72 is not a perfect square, but if you think about your list of perfect squares, 36 times 2 is 72. So if that 36 comes out, the square root of 36 is 6. I leave behind the 2. Whenever I take a square root, I have to throw a plus or minus sign in there. So I get plus or minus 6 root 2. So this one would hit the x-axis 2 times, once at the positive, once at the negative. Number 9. Again, we have one spot with one variable, so I'm going to algebraically get that by itself. First thing I have to move over is that 10. So I have 10b squared equals 480. Divide both sides by 10. You cannot take the square root until whatever is being squared is by itself. Once I have that by itself, I can now take my square root. The square and the square root cancel. So I'm going to be left with b equals 48 is not a perfect square. However, what is the biggest perfect square that goes into 48? 16 times 3. When that 16 comes out, the square root of 16 is 4. I still have my square root of 3 on the inside. I took a square root, so I have to throw a plus or minus sign in front of it to leave me with plus or minus 4 root 3. So that graph would hit the x-axis 2 times, once at the positive, once at the negative. All right, one last one. So the I step. Remember, the square root of I, or the square root of -1, not solvable. So then it got a definition. The square root of -1 is I. And what this allows us to do is if I want to solve this equation, I'm going to start by minusing 1 on each side. So I minus 1 from each side, I get -36. Take our square root. So the 36 part is good. Like the square root of 36 is 6. This negative though, we cannot take a square root of a regular -1, so we gave it a definition, and whenever we take a negative outside of a square root, it turns into an I. So the square root of 36 is 6. The square root of the negative sign is an I. We took a square root, so we have to throw in a plus or minus. So whenever you take a square root of a negative number, the negative comes out, it turns into an I. This is the imaginary number. Big picture, it will not cross the x-axis. So this is our non-real solution. We get an imaginary solution.